Welcome to the Low Earth Orbit Payload Delivery Launch System. In Proposal 1, we see a persistent superconductor. This is magnesium diboride in a double-coiled helix configuration solenoid. We're running it in a vacuum with liquid nitrogen, and we're running DC through that, DC power. There's two coils. There's the alpha coil and the omega coil. When the DC electrons singles hit the super cold, high critical temperature at 39 Kelvin magnesium diboride, through translational symmetry, they are squeezed together in the lattice and they form pairs and they fly through there with unencumbered or unimpeded. And that gives us our superconductive state at 39, this critical high temperature of 39 Kelvin. Now we turn off the DC and that B naught field just keeps circulating. And then below that we have the smaller payload pod. And not only does it have a superconductive state itself, but it also has a core of a superferro material, and it has a B naught field and an H naught field. And so when we hydraulically press that 1000 kg payload pod up into the persistent B naught superconducting field of the superconductor, they are attracted because they're opposite charges. At the bottom, the charge is south or negative, and at the top of the payload pod, it's north or positive. So opposites attract. And then once it gets into the field itself, it switches and reverses polarity so that the south is now attracted to the north at the top, and then it is fired out the top into low Earth orbit. And the payload pods can vary in size, and the payload pods are also shielded. Once they exit the vacuum of the superconducting unit, they enter the Earth's air atmosphere, and they are shielded by an air blast through the top of the payload pod to reduce air resistance. Thank you for watching.